Right. Curved surface formula and its applications are given in the example 1, 2, and 3. The very important problem is first one, bird problem. Right. What are the options? It is observed by the fish at farther than actual position, and it is observed by the fish that bird is moving faster than its actual speed. So how to solve? Yesterday you observed and you learned also. Then now we are moving to another topic, that is here simply what is a lens. Here lens is a simple device application of light. Here simply a lens is made up of a transparent material medium, right? It is made up of a transparent material medium, and it has at least two surfaces made up of, not at least, it is only with two surfaces, right? It is bounded by two surfaces, and the two surfaces, at least one of them, among the two surfaces, at least one of them compulsory curved surface, right? So if anyone asks you about what is lens, you need to say it is made up of a transparent material medium plus maybe glass or maybe other transparent material, but it is having two surfaces. Among the two surfaces, one must be with curved surfaces. If two also curved surfaces, there is no problem. It is also a lens made up of one curved surface or made up of two curved surfaces among two surfaces, right? So this which satisfies that we can name as lens, right? Then here one more question to you here. What is that? Simply, what happens to the light ray when a transparent material with two curved surfaces is placed in its path? So here light is propagating in a certain direction, right? If you place any lens bounded by two curved surfaces, what happens? Will the light ray remain same in its path, or will it changes its direction? That we need to learn. If it changes its direction, what is the direction of that deviated light ray? Can anybody? What happens if you instant a light ray on a lens? That is only your question here. What happens to the light ray when a transparent material with two curved surfaces? Transparent material with two curved surfaces is what? Simply now only we learn it is called as a lens, right? So here a lens is placed in the path of a light ray. What happens to that behavior of light ray? Will it remains with same behavior or changes, right? That we need to learn. If it changes, what is its behavior after refraction? So it is changing means that phenomenon we can call it as refraction. So that light ray refracts, right? After refraction, what will be the direction of light ray? In all cases, that light ray will refract, or in some cases, that all the things we need to learn. Are you following? Is it clear? Right. So here, just we are moving to the topic. Before going to that, I need to know about lenses first. So I learned what is lens. Are there any types in the lenses? That I have to know. So I know about surfaces first. What are the types of surfaces you learned? Anyone? What are the types of surfaces you learned? Anybody? Rohit? Types of surfaces I am asking. What the surface is on the screen now? What surface is there?
Plain surface.
Very good. It is plane surface, right? So here now I have one more surface, but here I am covering this surface some part. Now what the surface you can see here. From any side. From left to right or right to left. Suppose from left end to right end. In this direction. What the surface is. Richard. What the surface? Convex surface. Then what about the surface from right end here?
Concave surface.
It is concave surface, right? So this is plane surface. So we have idea. So based on that, I'm going to design now lenses, right? I'm designing the lenses. Look at them, how to design them. So here, first of all, I'll take surfaces, right? What I know. Based on that, I'll name that lenses. That only we call them as types, right? So types of lenses we are learning now. So here, what the surface you have on the screen now? The surface is what? Fast. Plane surface, right? Plane surface. One more surface I am making here. Just look at on the screen here. The first one remain plane surface. Then the second one is from right end you are observing.
Curved surface.
Curved surface. Especially name.
Convex surface.
Surface. So both together we can name this lens as plano-convex. Plano-convex. Clear? First surface is plane, then the next surface is convex. So plano-convex. Like this we can name. Then here I am moving to the second one. I'll take the plane surface, right? So here drawing the plane surface, then second surface I am taking like this, right? Look at that. What is first? Plane. What is next? What is next? Second surface. Concave. So both together, I am calling this type of lens as plano-concave lens. I am not remembering the names of lenses. I am not remembering the shape of the lens. Just blindly with the surfaces, I am naming the lenses. Are you following me? Is it clear, everyone? Right. So here now, I'm moving to the next one. That is here. First surface, I taken like this. What the surface from left side? This side. What the surface is? Concave. Right side also taken. Similar to the first. From right end, what the surface you can see here? Both are what? Concave. Both are what? Concave. So here, two surfaces, right? Lens has two surfaces. That lens, two surfaces are concave. So here, double concave surface, right? So we can name it as double as bi here. So this lens is biconcave lens. This lens is what? Biconcave lens. Then I'll move to the next combination. So that combination I'm taking here by the convex surfaces. Either sides you have the same type of surfaces. One is left side convex and right also convex. So both are convex. Double, we can name it as biconvex lens it is. Right? Any other combination possible here? So plane convex completed, plane concave completed, concave concave combination completed, convex convex combination completed. Then opposite, convex concave combination, right? So I will take first here concave. Then from the right side, I'll take convex surface. Then both together here called as, one is left end concave, right end convex. Then both together we can name it as concavo convex lens. Then another combination is left surface is convex surface, right surface is concave surface, right? So left surface is taken convex and right surface is taken concave, then making that three-dimensional. So here finally we can name it convexo-concave lens, right? Clear? What are the types we have? You need to remember them. Do you need to remember them? Anybody? Is it compulsory to remember the names? No need. Just you know the surfaces, right? By knowing that surfaces, you can design your own lens in the diagram by taking the different combinations, then name it. First surface is first part, prefix, then second surface is a suffix. So combination will give you the name. Plane convex, plane concave, concave concave double, right? Convex convex double by, then concave convex combination, convex concave combination. So these are the typical lenses, right? Some different types of lenses, right? We have or we are using in our daily life, right? So here, especially in this lesson, we are not dealing with all the lenses. We are only dealing with the lenses here, especially double concave and double convex lens. Double concave and double convex lens. Clear? Are there any doubt in the types of lenses? So no doubt. Okay, let us move to the another topic here. That is here simply in this type of lenses only. Again, I am classifying the lenses what I named now. How many I named? 6. So that 6 again I am classifying based on the behavior of light rays after refracting from that particular lens, right? Suppose if I take a convex lens, what happens if I incident the parallel beam of light rays on the convex lens, right? So here look at the screen. What happened after refraction from the lens? Which lens I taken here? What the lens is taken on the screen to incident the parallel beam of light ray on it? Kaushik.
Biconvex.
By anybody?
Convex.
Okay, it is what? Biconvex. Okay, this is what? These rays, parallel rays, right? Incident on the convex lens. After refraction, what happened here? After refraction, what happened here? That light rays are going to meet at a common point. Here, look at. Yes or no? You are getting one common point after refraction. So this point we can call it as, that point we can call it as converging point. We can call it as converging point, right? So which lens will give you converging point after refraction, right? Which lens will give you converging point after refraction? that lenses are called here converging lenses, right? So here, these are the types of lenses which are giving you converging point after refraction. So look at, how do you remember them? Sir, it is confusing me to remember that. One logic is there. If you observe that diagrams clearly, can anybody identify that logic? Can anybody? See here, I need to observe the converging point. So here, what I have right side surface to each other. Your audio is unclear. I think you are using headphones or microphones. Just disconnect them. Speak in loudspeaker.
Sir.
Right side surface is for all convex surface, right? Then observe them. They are having the sharp edges. Clear? Right side surface is convex, whatever it may be left, but look at here, sharp edge. Okay, so these are converging in nature after refraction. Then I'll go to the next one. Is there any other behavior? So converging is taken, maybe they can move away from each other. That point we can call it as diverging point here. So look at the screen here. What type of lens I used here? Concave, biconcave lens, right? Biconcave lens I used. So what happened? All they are appear to separate from a common point after refraction. So this point is called diverging point. This point is called diverging point. So here, this lens is called diverging lens. This lens is called diverging lens. So convex lens is converging lens. Concave lens is diverging lens. So I give you two more names. Right? What they are? Concave and convex lenses. Known as here diverging lens or converging lens. Concave is diverging. Convex is converging. Okay. Then here, look at which lenses are diverging lenses. So among the 6, I selected 3. What are the remaining 3? That 3 are in this nature. Right? Plano concave, convexo concave, and a double concave or biconcave. So these are the types of lenses we classified into another category based on the refraction of light, which are not given in your textbook. Not given. Okay. In your higher classes, you will learn about these type of lenses. Clear? Any confusion? Why they are called as converging? Why they are called as diverging? Based on the behavior of light rays after refraction from them, right? So only we can observe with parallel beam of light rays. Okay, and they are parallel to the principal axis. What is principal axis? We will learn. Okay, so here we are moving to another topic, that is here simply terminology related to the surfaces. What surfaces here? Two surfaces bounded by that called lenses, right? Bounded by that surface, that is called as here lens. So simply I'll go to take one of the lens, right? So here what lens I used on the screen? Which lens? Name it.
Biconvex lens.
Very good. It is biconvex lens because left surface and right surface both are bounded by convex surface. So this is named as double convex or biconvex lens. right? Suppose if I extend the curvature of the surfaces like this, what you see, it is isopod in the sphere because it is 3-dimensional. Isopod in the sphere. So what about left surface? Also in the part of a sphere. To the part of same sphere or different spheres? Tell me. Tell me. Anybody? Do they part of same sphere or different spheres? Right. I have a sphere. Can you see that? I have a sphere which is given by me in black color. Right. Now what I am doing here, I am trying to cut this into different parts. Right. So here I'll make, sorry, not visible. I'll make a part as you see here. Right. I'll make another part. Okay. Now look at. I'm asking you only the part you have here with this red color shaded region. This one. Is it looking like a lens or not? This highlighting part. Anybody? Anybody? Vikrant.
Yes, sir.
So it is a lens, right? There is no doubt to accept here as a lens. Okay. So this is what for us? Lens. Is it clear? It is a lens. Okay. Here I am asking you, what about this curvature? What about this curvature? Do they have same radii? Do they have same radii? No. Here, they are not having the radii as same, but they are made up of same sphere. Is it clear? I made this lens by using the same sphere. If I cut like this, I'll get two different radii for two surfaces individually. This I am trying to say. So you are able to make a lens using the same sphere. Okay. So now here you have the different radii. Okay. So they have centers or not? If you imagine this as a complete sphere, so this is, I take as first surface. So what the first surface is, this left surface. So left surface has its center towards right or towards left. Which side? Its center located towards right side, right? So here I am going to identify its center, and it is named by me as C1, because first surface center I am naming as C1. Is it clear, everyone? Why I taken that as center? Why I named as first one C1? Because it is first surface and it's centered towards right side. Okay, then I'm taking or imagining This is a complete sphere now. So where its center will be? Towards left side, and this surface is what? Second surface of the lens, right? So here always I am following the direction what we followed for writing in our notebooks, left to right. Okay, so left surface is first surface, right surface is second surface. Okay, so right surface is second surface, its center is located left side, so that I am naming as C2. Are you clear? Yes. So now I got centers. How many centers are there for a lens? 2 centers, because lens is bounded by 2 surfaces. In this chapter, we are dealing only with 2 lenses. One is double convex lens and the other is double concave lens. So it has 2 curved surfaces, 2 centers. Okay, 2 curved surfaces, 2 centers. So C1 and C2. Okay, then here I'm taken one more point where it is according to the lens. Where it is according to the lens. For your convenience, I am giving you a line to connect. Look at that. For your logical understanding, I am given like this. Understand. So vertically, horizontally, I drawn bisectors. Right? So where they exactly coincide, that point is taken. Right? So simply here I am naming that point as pole here, or also called as optic center. Also called as optic center. So here simply that point is depicted or identified by me. Exactly it is middle. Exactly middle in its thickness. Right? So that point here I am giving you as pole here. Right? Pole, or also called as optic center. Right? Then I am joining the centers of the lens. How many centers are there? 2 centers. The 2 centers are joined by a line. That line which is joining the 2 centers, right? That line which is joining the 2 centers of the lens called as principal axis. Principal axis, right? Or also called as optical axis. Okay, this line is called as principal axis or optical axis. So any name we can use. So don't get confusion, right? Is it clear? Then I'm connecting the center and the curvature. So what you can call this size? What you can call this size? Red color line, dotted line, that which is joining the boundary or the surface of lens and its center. Surface of lens and its center. That line is what?
Radius.
Radius of curvature. Radius of curvature. So we can name it as R1. Why I named as R1? Why not R2? Because it is first surface center that is connected with the first boundary, first surface, right? So that's why it is named as R1. If I did that same thing towards left side, connecting the center with the boundary, second surface, second center, second surface with the dotted line. So that line is what? Radius of curvature for the second surface, naming as R2. So how many radius of curvatures are there? 2 radius of curvatures. How many centers are there? 2 centers. Clear? Any confusion? Go to quick reaction. If there is any confusion left, immediately raise your question. Surajita, Tejaswini, Vikrant, Rohit. Okay, so everyone is clear. This is called the terminology of the lenses, right? Two more points we will learn related to this only, but based on the behavior of light rays. These are irrespective to the light rays, right? Then remaining terminology based on the behavior of light rays after refracting from the particular lens, that we will discuss. So here the next topic is, this is given in the figure number 7 in your textbook, page number 65. You can find it. Then we'll go for another topic, that is here simply focal length of the lens. Focal length of the lens. So here, what happens if parallel beam of light rays incident on a convex lens? So here I need convex lens, right? For this, I need convex lens. So I am drawing the convex lens. Okay, then identify its centers, name them eyes respectively C1 and C2. So right side C1, left side C2. Then identify its pole after joining the centers. So two centers are joined. That line is what? Principal axis or optical axis. Then a point is located in the middle of a lens on the principal axis, that we can call it as pole or optic center. So this is first thing. Then here your question is, what happens if parallel beam of light rays incident on a convex lens? So I am taking the parallel beam of light ray that is parallel to the principal axis actually, right? Parallel to the principal axis. Okay, one condition I am applying, parallel rays and parallel to principal axis. Okay, so here what happens? Can anybody guess the behavior of light rays?
Sir, they all are converged at a point.
Can you explain me how they can converge based on the point you learned? They bend towards the normal or away from the normal when they changes its medium.
Sir, towards normal.
How can you satisfy me? If I take normal, which side I have to take normal? Left side or right side?
Sir, right side.
Which is right side? Normal?
Yes, sir.
No. No. Here simply just one condition is there. I'll remind you that condition. Here, whatever it may be, you are discussing or dealing with the lens, right? Up to now, we deal the surfaces only with one curved surface, right? Now we are dealing with two curved surfaces, right? So here we are expecting that light ray bends 2 times. Yes or no? Because here once it is changed its medium, and while it is coming out, here also it can change its medium. So we are expecting 2 times refraction. Yes or no? Commonly. Right? Here commonly we are expecting 2 times refraction. But in this chapter, we are not taking that refraction 2 times. Just we are taking the refraction. We are taking the refraction only once. Because here the thickness of the lens is less comparing with its radii, very less. So thickness of lens is negligible, right? So in this case, we are treating that light rays propagating from air into the lens without any deviation. But while it is coming out from the lens, we are giving importance to the refraction. Can you remember this logical point? We are dealing with this point only. Is it clear, everyone? No importance to the thickness. No importance to the thickness. Only we will give the refraction importance from the right surface, not towards incident light ray direction. Clear? Refraction expected only from the second surface. So keep it in your mind. This point, keep it in your mind. Okay. So I'll close this meeting. Immediately join in the next meeting.